So welcome everyone to the TalentJourney's third day of this TalentJourney course about the IoT data-driven systems and ERP. Today we will be talking about cloud systems. So this is basically a continuation for the previous 2 days. First day we focused on the factory floor, on the communication protocols. Second day we had a hands-on example about one cloud solution, no-code, low-code platforms. And today we will take a look at the whole orchestration of things. So connecting things together ground up from sensor to cloud and from cloud to cloud. My name is Veli-Pekka Salo. I'm working in a Vapais as a team leader in IoT and communication solutions and holding this course today. Someone is still coming. Let's invite. Hello, Peter. Good afternoon.
Sorry that I'm late.
I already started, and to let everyone know, I also started the recording and had a very short introduction already. But let's continue. So today we will be focusing on the cloud systems ground up from sensor to cloud and cloud to cloud. Today's material is quite technical. Please stop me at any time again if you have questions or if something was very strange. I don't expect everyone to understand all the time what is kind of the details or what is happening in the details, but I will explain always the big picture what I'm doing. Same time. I believe in examples, so I will be using the Microsoft Azure as an example for cloud services. We are at Vapais, we are Microsoft's partner, or Microsoft is our partner. We are providing some services together. And yeah, here is one more time today's agenda in more detail. So there is introduction to cloud computing services, Azure as an example, MQTT. So we already earlier days we discussed about the publish subscribe pattern and how some of the communication protocols operate using that. Today we will have a very short introduction to MQTT. It's very popular in IoT communications. Then we already had a really short touch also to software project processes. I will be talking shortly about the DevOps, how it changes the thinking in software projects. We will be talking a little bit about infrastructure as a code, and then some insights how to create an IoT strategy, or let's say digitalization strategy. So cloud computing services. So the big picture here is actually that if you think about, let's say, modern industrial IoT systems, they don't necessarily rely on one single platform anymore. They more and more there are many platforms playing together. It's like an orchestra, and things have to be there are connected things and things that can be done with many different ways. So cloud computing has become very popular because it offers a wide range of possibilities to operate different kind of services. So Microsoft Azure is one example of this kind of cloud computing or cloud services. So this is a cloud computing service created by Microsoft, and it's possible to build, test, deploy, and manage different kind of applications and services. And those applications and whatever you create using this service, they are managed by the Microsoft managed data centers. And there is a software as a service. You could have platform as a service. That would be, for example, the development tools, or infrastructure as a service, which would be, for example, a different kind of virtual machines, storage, and so on. So this creates enormous possibilities because you don't have to deploy these by yourself anymore. You can again focus on creating business value, not and kind of forget how to operate the machines, how to operate the platforms, forget the IT operations that are mandatorily related to this kind of tasks. So Microsoft takes care of those, provides you software as a service, platform as a service, or infrastructure as a service, or all three together. Then there's also something called functions, function as a service. So this is part of Azure Cloud Computing Services, and it basically allows building a serverless application. So this is a new thinking that you don't necessarily have your application running all the time. You only execute it when needed. You only pay when for the consumption. You only pay for the function execution time. And this doesn't require any server process that is constantly run. There is, of course, a penalty in this that it might take a little longer for the request to take place. But once it's done, then basically the function makes what it's supposed to do, and then stays in alert for any other tasks. And if nothing comes, then it goes into a sleep mode again. So some examples where this could be really useful is you could have some scheduled data processing, you could have serverless web apps, you could have serverless mobile web apps, you could have Internet of Things data processing, or you could have for example, Azure service event related processing. Today we will actually have an example about Internet of Things data processing in Azure functions. Here is a short introduction about Azure, how to start. So basically you can sign in, get a free account. For small operations, there's actually a lot of possibilities that you can immediately do in Azure. So for example, Azure functions, there are 1 million requests per month is free, or event grid, there could be 100,000 operations per month. So actually you can do a lot of things which are completely free. And then only when you really deploy your commercial applications, then you start paying for more and more services. So here again, it's really simple to start from something small to test if your if your app, how well it responds to the business requirements. Does it really work? Does it provide what it's supposed to do? And then you can, if it doesn't, then you can reiterate very easily and try it again. And once you see that it's okay, this is what I want, then you can scale up, and only then you start paying for more and more services. Okay, some concrete example. I will come to the big picture piece by piece. So if we think of, let's say, IoT platform where multiple IoT platforms communicating with each other. First of all, we would have a set of devices bringing the information from the field. So some assets that you want to follow. So there is of course the problem that how to bring the information from the field to the cloud first. You would have your devices and you need some kind of communication protocol. And MQTT is actually really good for small embedded devices that might have some hardware constraints. The name MQTT comes from MQ, telemetry transport, what was previously known as message queuing telemetry transport. There's a lot of examples and information available in net, but basically it's a lightweight publish subscribe messaging transport designed for machine to machine. Clients are very small and require minimal resources. So this is exactly what you want if you have, for example, smart city applications or sensors that are relying on battery power. It's bi-directional, so you can bring information from field to cloud, or you can also communicate from cloud to field. It's scalable, security enabled, and yeah, fast becoming one of the main IoT protocols. MQTT requires this kind of central broker. So you are publishing messages using a topic. So your topic could be, for example, temperature. And then you have the subscribers, which then subscribe to listen to the topic. So it's up to a subscriber to listen into different kind of topics, and then the broker takes care of delivering the messages to those subscribers that are subscribed to listen to the topic. So broker is like a delivery guy delivering the messages to each party. Today's example, I will be using the Azure IoT device SDK, which is again freely available in the GitHub. And there's a lot of benefits of using this kind of ready-made SDKs. So you can create future-proof solutions with minimal code. You can focus again on your specific business needs, security, device management, reliability. And you can also, there's a different languages available, so you can develop with preferred language for different platforms. For embedded devices, there would be C language. For more sophisticated devices or machines, there would be the C#, Java, Node.js or so. And you can benefit from the flexibility of the open source with support from Microsoft and community. So quite often if you design something, there's always some problems, and you want to perhaps ask from the community the question, or perhaps someone else has had the same problem to tackle. Okay, so using the device SDK, I will actually play a simulation of sensors, and we could actually look at the demo architecture here. So today I will again use the IoT ticket as let's say the final destination for the data, where I will do the visualization and collect all the data from the field devices. This would be the ERP layer in our automation pyramid. So this is the place where all the factories, all the field devices, or information from those is collected together. Then I would have this kind of let's say PLC SCADA layer here, where I take care of provisioning the devices. I will basically using the Azure IoT Hub, it will be possible to provision the device, take care of how the sensors are managed. And then this is where I aggregate the data together, and then I send it to the IoT ticket using actually now Azure function. And then the devices here left, they are actually then taking care of collecting the data from field and publishing the data using the MQTT. And why would actually someone want to make this kind of system? So it's of course clear that sensors, they need to communicate with something, but why not directly to IoT ticket? It's actually using the Azure, you can separate the device provisioning and device integration completely away from the IoT ticket, because this field is of course changing fast. So there is the sensors, what kind of sensors are available in the market, what kind of protocols are available there. This is evolving very fast, and it's probably very tedious task to keep in pace what is happening. So here in Azure, we have actually really good tools for provisioning the device and taking care of how the devices are managed. And then perhaps you want to focus on creating a world-class dashboards, or just focus on the creating more business value, for example, analytics or such. So what you want to do is just collect together, aggregate all the data from the sensors, and then send it somewhere where it's then further post-processed. So here we have implemented the complete orchestration of device management, data aggregation, and post-processing. I will go a little bit back here. So yeah, we will be using in the devices. I don't have the real devices now. Like yesterday I had the mobile phone, but today I have to admit I'm simulating my devices. So I'm using a C# language and Azure SDK libraries for simulating a MQTT device. Those will mimic my sensors and send some key KPI values from field. Everything I created using a C# language. Don't care about details in the C#. Maybe someone is familiar with it, maybe not. But this is a language created by Microsoft again as part of its .NET platform. It's meant to be simple, modern, general purpose, and object-oriented programming language. And this syntax is quite similar if you ever used, for example, Java language. So you are able to create classes, for example, something very familiar in object-oriented programming. And yeah, it's quite self-explaining language, actually. For example, compared to the C language. In Azure, we will have some example components, like we will utilize subscriptions. So this is actually in Azure, when you register there, the subscription is your Azure services and features. Then we will utilize resource groups. So this is almost like if you have if you have played, for example, with some PC tool, you probably what you do first is you create a project. And under the project, you will be starting to develop something. So resource group is like a project which collects your items and structurizes your work in the Azure. Storage account would be something that contains your data objects, blobs, files, and so on. IoT hub is the IoT thing, or the Internet of Things connector in the cloud. And then the functions are the stateless functions doing some task. And then you would have also a key vault, which then stores, for example, secret items. Here we have a key vault here. The interface to the IoT ticket is HTTPS. It's a REST API. So we will actually store the key vault data in, or the REST API username and password is stored in the key vault. And then the function actually accesses the data from the key vault and doesn't directly use or you can avoid directly using the password username in this application, which then increases the security of the interface. For example, the application developer doesn't need to know what is the username password. It's only some administrator who is able to access the key and then only gives a reference to the, or it's kind of a reference for the function that then allows the get it in under the hood. Okay, let's actually now take a look at, I happen to have Vapis's Azure here available. So if we go to home, actually I want to go into all services here. So when you log into the Azure, this is what you would expect to see. You have lots and lots of tools available here where you can start creating, but you have, for example, functions. You could create databases. You could create virtual machines to host applications. Of course, you can also, like, you don't necessarily create a function. You could create a normal application that you host in the Azure. In that case, you would just create a virtual machine and then deploy your application there, and it would run as similarly as any application. But today we will be creating a function app. We could actually work here so that we could create a resource group, which was our let's start creating it. So resource group was our project. So we could start creating a resource group. It would be, for example, TalentJourney. And then we have some naming convention for resource group. Okay, TalentJourney RG we seem to have already, but let's make it a resource group 2. Then we can assign a location for our service. So Azure has machine rooms in different parts of the world. So you can actually allocate a location near to you. So we could be North Europe or West Europe. West Europe would be fine. Then our IT happens to require some tags. So tags are just organizing and categorizing your items into Azure. So we would need, for example, create a date. I think there could be like this, and then how long it is valid. Let's put it end of this year, and then owner. This of course could depend on your organization, and if you just create your free Azure subscription, then probably there is no tax needed at all. Then review and create. So we create it here. And it says it's creating the resource group and TalentJourney resource group 2. Okay, so now we have our first Azure component created. Now we could start creating more here under the resource group, or provide access rights to this resource group to my developers, for example. I could add, for example, key vault. I could add functions and so. But let's actually, I happen to have in the TalentJourney RG, I happen to have everything ready here. So first of all, we could take a look at our sensors. And like I explained, my sensors are simulated today. I don't have real life sensors. Actually, let's take a look at the IoT hub and other components here. So key vault, this was needed because we want to store our secrets. So let's see. My key vault here should have the secrets here. And I happen to have the IoT ticket username and IoT ticket password. So this would be in real life, some administrator would have given the access rights to IoT ticket to access it through the REST API, and this is what we would be using in our application. Then we will have the function app. This is actually where the function is running. We have actually an MQTT trigger function. So this function is called every time when our device sends data into the Azure IoT hub. It receives the data and is then triggered automatically, and it triggers a HTTP REST call to the IoT ticket, and it posts the data there. Using this Azure interface, we can see, for example, we could monitor what is actually happening here. We can open a monitor and open the logs, and it would connect here, and it would show what is happening in the function. We will actually see that shortly. Then the storage account, that was for storing let's say the static items, and in this case I don't actually need, I don't know actually exactly what it stores. In this case it's storing some function needed resources, which are automatically created in this case. And then in the IoT hub, we have the IoT hub here. Here we have important thing, which is the IoT devices. So this is actually where the devices are provisioned, and there is, for each device, there's an endpoint created here. So this is the demo device, which is this demo or the endpoint for demonstration in this course. And it's again something Azure creates automatically. I have a connection string then, and this connection string is used in the MQTT protocol. Again, we don't need to know exactly what is happening under the hood. It's basically a connection string that MQTT just needs to know to be able to connect into this endpoint. Okay. Now I can actually go into the program here, my sensor. So here I have the same connection string. It's just now configured in the application, which is not, of course, not, let's say, not very good to hard code it here, but for demonstration purposes, I can do it. And then we simply create this MQTT client using the connection string. So that's a one-liner here in the code. And then we will create some demo data here. So temperature, humidity, velocity, and then latitude, longitude. This is the information my sensor is providing. And then I have a short identifier I'm using inside the IoT ticket for creating the structure inside inside the IoT ticket. And then just sending the data. It's actually the device SDK takes care of everything else. I don't need to know about the MQTT protocol details. I will just call send event async. And async means asynchronous, so it is no non-blocking call. So it will just shoot the data towards the cloud and then continue operating. And under the hood, the program takes care of sending the data. Then I have the MQTT function, which is then a trigger function. This takes care of reacting to the IoT hub events, and then it uses the IoT ticket REST API to send or forward the data. And we could actually see these in the action. So let's start our sensor. So we will open the application and it will start sending the MQTT messages. This is basically the data, so temperature, which is now completely simulated, humidity, velocity, and so on. Also the position of the sensor. And we can minimize these because we are not interested in these. We could go look at what our function is doing. This is now previously deployed into the system. So we should, first of all, I would like to see some events here. So let's go to the trigger function. And interestingly, I don't see any executions. Let's see the monitor. Okay, here is at least today something happening. Let's open the log. see what happens. Okay, in the log we actually see something happening now. So we are executing our stateless function. So this is now function as a service. If I close the sensor, just pressing Ctrl C, the function also goes into the rest state. So it takes, of course, some time, but once Azure notices that there's nothing happening there, then it goes into a silent mode and then stops doing. Okay, I need to start it again. Okay, the sensor is alive again. Then I have the IoT ticket interface here. So here I have again created the demo dashboard for receiving the data. So I have a as a visualization, I have a Raspberry Pi picture, and I've connected the humidity, temperature, velocity here, and I have some graphs showing data flowing here. So I have the humidity, temperature coming here, and we can see that our function is now collecting the data here. And I think we should see it even moving somewhere. Oops, now I'm in edit mode. So if we go closer to the simulated position, I think our sensor is even moving somewhere. Okay. So it's getting now real life events from the sensor. And so here we have a complete orchestration of cloud services. And what I want to highlight here is again the possibilities of different kind of services and platforms available. So in the IoT ticket, we are utilizing the no-code, low-code environment. So we are creating the visualization really quickly, creating different kind of interactions with the data, collecting with the data, and we can do that really fast. In the Azure, we can orchestrate the devices. We can provision the devices really easily. If there's let's say now we had only one sensor, but what if we have 500 sensors, or we have 1,000 or 10,000 sensors we need to configure for getting the data? Then there is even Azure IoT provisioning services available. So you could mass deploy different kind of settings, mass deploy provisioning for the sensors, and let the Azure IoT Hub take care of that. And then our stateless function as a service is taking care of the data aggregation. So that collects all the data. So using two cloud platforms, IoT Ticket and Azure, we can achieve a really fast productivity and really nice data collection flow or tool chain. And this kind of tool chains, they are really in key importance in modern IoT systems. So when you are creating a complete solution, you probably have a tool chain of different tools. One stage is collecting the data. One stage is maybe buffering and stream processing the data. We could have, for example, in the IoT ticket, we are doing already stream processing by computing some key values like mean, maximum, minimum, average values immediately. So you could have a stream processing, and then you have a data collection and storage, and then you probably would have a post-processing. You want to do some advanced analytics maybe for the data. So most probably you will not use one single platform, but multiple platforms. And this is an example of this kind of cloud orchestration. Then when we think of the life cycle of IoT project again, this is where the DevOps again comes into picture. So we already saw that you don't have necessarily one single platform. You will most probably have multiple tools and tool chains in your solution. So it's evident that the IoT solution might be really complex. And then you probably don't want to implement your solution so that you have a traditional way of doing the software management. So you probably want to have very fluent interaction with different stages of software development. So you, of course, you start from the innovation, start creating something, but then you will have your product tests and let's say the environment where you work. So you probably want to automate things. And this is actually the DevOps. So DevOps comes from the software development and IT operations. So automating things actually makes your software processes very much more productive. So what you want to do is probably that immediately once you implement new code, you would have something called constant integration. So you start all the time, you run the same tests for your code, and you get immediate feedback already from your test systems. And once you automate the tests, you make the unit tests and you make a system test automation as much as possible. Then you get early feedback of how did you software process succeed. And you don't need to wait for the end user feedback. You already get very early feedback from your automated tests. And cornerstones here are that there's some tools, some practices, for example, collaboration, like code review, task planning, monitoring, chat. So you of course need very close collaboration with each developer. Then you need recreatable and maintainable development environments. You have to have sophisticated methods for creating your or deploying your development environments so that they are similar always. That you don't get mistakes because something is missing from certain environment also. Then you need test automation frameworks, verification and analysis tools, and continuous integration and deployment pipelines. And then infrastructure automation and scaling also. And then also DevOps cornerstone is quality culture. So agile and transparent work planning, priority on quality, priority on workflow improvements, and avoidance of strict developer roles. So you want to have a most probably want to have like everyone is capable of doing all tasks needed in development process. You would need architecture which is encourages automatic deployments and proper interfaces for high testability, and technology selections for seamless DevOps tools integration. And then feedback, so fast automatic verifications to prevent issues as early as possible. So the earlier you find the problems, the cheaper it will be, because if your bugs or mistakes, if they go to the field and if customer needs to report them, then always it's more expensive to fix it. And continuous monitoring and measurement, both qualitative and quantitative, and end user profiling and feedback. And DevOps is really a silo breaker. So traditionally there used to be separate teams. So there was developer teams and there was testing teams, so quality assurance, and then there was the operations team. And DevOps basically removes contradictions, and there will be cross-functional teams. So teams that are able to develop, test, and operate the system. And actually Azure, there is also a DevOps available. So Azure is a platform that not only allows the development, but it also steers the software processes into correct direction. So you would have tools also for that. You would have Azure repos. This would be the place where you store your code. Boards would be places where you document and plan your tasks. Pipelines would be automated tasks that, for example, they build your code. So, for example, you create a set of unit tests, and using the automated pipelines, you can then deploy a test built every night, for example. So you get immediately feedback when you next morning when you come back to work, you have a nightly test results available, and you know that okay, now I need to do something might be broken again, or something. You get immediate feedback if something is broken. You have the test plans, so you can plan your tests. Artifacts is then basically the results of your pipelines, and where you can, for example, the build pipeline would create the installation files that you need for customer installations. So this is the place where you host the installation files and packages. So Azure basically supports this natively. But then if we take a look at Azure here, so looking already at the resource group, and if we go to TalentJourney resource group, we can see that this is now one environment where we are hosting our applications. And it was already quite complicated to create the resource group and then maybe create the key vault, create the IoT hub, and so on. So, and this is not even a complicated application. It's quite simple application actually. Just a moment, I think I'm in the wrong slide. So let's think about the software project. So most probably we would have some local development that happens in the developers' machines. then we would have some development environment for early tests and some environment for what is meant for more like a preparing for releases into production. And then you would have the production environment. And you would have let's say 3 different environments: development, staging, and production. And how do you keep these consistent if you use, for example, a user interface for creating the items here? Or then if you suddenly need a new staging environment or new development environment, new developer, for example, comes into a team and needs a second or new development environment. How do you create it from scratch easily? For this purpose, you need automation. And this is where the DevOps automation comes in place. And it's not possible to create the environment anymore using like a user interface. You can't do it from the user interface anymore by clicking and adding the items. In this case, we are quite often talking of a concept as a infrastructure as code. So what you want to achieve is that you start managing your infrastructure using source code. So for example, you use the exactly same versioning in DevOps as you would use for the source code. And this actually solves really nicely some problems. So without the infrastructure as a code, each development environment would become unique. And it's impossible to reproduce the environment automatically. And then you would inevitably have problems in deployment phase. And this infrastructure as a code, it prevents what is called like an environment drift. So you so you can avoid manual configuration, which would inevitably happen if you have a manual environment. So someone would need a feature that you configure there, then you would, in time, you would need more features that are configured a little bit here and there. And finally, even if you try to keep a log file, what has happened, then you don't know anymore what has happened in the environment. The other environments would be different, most probably. Infrastructure as a code, you can generate the same environment every time similarly. And this is one really key things in modern or when deploying the modern cloud services. Some other benefits are that it's actually easily readable. So infrastructure becomes documented. So instead of trying to create a documentation that what was done in the let's say, for example, in Azure, the code then documents itself. You have well documented code formats like JSON or XML or YAML. And your changes can be validated and reviewed, and changes are versioned. What changes were made, when, and by whom. And it's easily repeatable. So DevOps teams can provision test environments quickly on demand. And then you would also have the operational certainty and disaster recovery. So you can, for example, you could have a service guys, they can use the infrastructure as a code for recovering your environment 24/7. So there's clear benefits for this. I will give a short example using a Terraform. Terraform is one tool for creating infrastructure as a code. So now we used Azure, but what if you change your cloud provider during your product development? Or you might have different cloud environments to work with. So Terraform is something called platform agnostic. So it's compatible with many cloud systems, Azure, Google, AWS. And you can provision infrastructure across over 300 public clouds and services using you can have a single workflow. And okay, you can go into Terraform and read more about it. I have a short demo. So this demo will set up a resource group in Azure. I have already installed the Terraform in my machine and added it to the path, so that basically finds the tool in the command line. Terraform then uses these TF files for describing the environment, and then I just use this init and apply for making the changes. So let's see. Okay, I happen to have the Terraform here already available, and let's take a look at what I have here. So here we have a very super simple Terraform script that actually creates the resources in Azure. So we configure the Azure provider, and then what we want to achieve is we make a resource group from using infrastructure as a code. So we define our resource group name. From our IT, those requirements, we need the tags, we need the created date, valid date, and owner. Okay, so let's see what happens then now. So we will first need to set Terraform init, which initializes the tool. And okay, it makes some magic by initializing it. And then I will just, okay, now I'm in the same folder where my main.tf file is, and now I will just give Terraform apply. And let's see what happens. For me, it's a very long waiting time. I see it should be doing something, but let's see. Okay, maybe I didn't press enter. I thought I was doing that already. So Terraform will inform what it is about to do. So it says plan, 1 to add, 0 to change, 0 to destroy. So it's going to add a new resource group. Location is West Europe. Name is WebS Terraform RG. And then the tags I asked it. Okay, it's actually, there was something wrong there. So it says apply cancelled. I think we have a famous demo effect now. Let's try to put yes and enter again. No. Terraform apply. Let's wait patiently now. Okay, now it works. And then I need to approve the changes by pressing yes. And it should start working soon. It's creating, and now it says it's added one, and so on. And we could actually go into the resource groups and check WebS testing. Okay, maybe it takes a little bit time. Not yet. What was the name? Supposed to be WebS Terraform RG. Always takes a little bit time before it applies in the cloud. And now I'm still waiting. Okay, there it is. Now we have the resource group, which is our project. As you see, it's the timing and kind of the how long it takes effect. It's always nothing happens in real time in the cloud system. So it took quite long time to get the resource group there, but now it's there. And we could make it a little bit more complicated. So I happen to have here a script which then additions here, which then adds the storage account and it adds the key vault also. So let's change our df script. We have the resource group, we have the storage account, we have the key vault. Let's make more components there. And let's now check what happens when I say Terraform apply again. Okay, again it says or shows what it is about to do next. So it's showing with the green plus mark the additions. So it's going to add 2 items into the plan, 0 to change and 0 to destroy. And I will just simply approve things by pressing yes. I seem to have some warning here, which is about an old, so something is deprecated or old. So some field is in the Azure is going to change into new and this will be removed. So now it has a little bit more stuff to create. So it's creating the key vault, creating the storage account, and it seems like it's taking a little bit time. Let's wait. And now it's nice to have at least some information what is happening. So still creating. Storage account was complete. Still creating the key vault. And if I remember correctly, it was just a bit over 1 minute it used for creating. And this time it's maybe a little bit more. Okay, everything done. So now I would expect to see, if I just press refresh, I expect to see my key vault and storage account here. Okay, there's still no keys here, but you could of course add the keys. You could add your functions and configure your application completely in the Terraform. So you can automate everything here. And I think you can already guess what happens if I say Terraform destroy. So you can really tear down everything here. So now I call the destroy. It's again thinking something. So it's about 0 to add, 0 to change, 3 to destroy. And let's approve it. And destroying, I think it will be a bit faster than setting up. Complete. Still destroying the key vault. I think I can already go here, refresh. Still destroying. Okay, I think we don't need to wait until it completes. The idea is that the whole resource group and everything inside it will be destroyed. So this is a great way of automating the creation of the infrastructure. This is something that you would be very beneficial to do when deploying the systems in the cloud. So now it's done. If I refresh, everything is down. Also, the resource group should be down. And you can create identical systems always using the infrastructure as a code. So now we basically covered everything from ground up IoT system, so collecting data, aggregating data, working with the tool chains, working with your software processes, creating the DevOps by using DevOps, by using infrastructure as a code. And finally, I want to talk a little bit about the IoT strategy. So and the component, a little bit more about the components of the IoT. So if we again think of our automation pyramid, and the whole communication chain from your field devices to the ERP and data processing. So there are different layers there. You have the sensor controller device layer. This is where your where your devices are, where you would be collecting the data. And quite often the layer where in the IoT systems, the layer where we have the devices is called edge. And edge level is a level where your devices are constantly running. They probably continue running there just fine, even if your cloud is temporarily not connected. You could have some peer-to-peer communication there, but and then you have the communication towards the clouds. You could also have a real-time data processing in the device level, and then quite often we hear the term edge processing or edge computing. So this is the data processing that is happening in the device level. And why would you do some edge processing is that you most probably want to do some edge computing already in the device and save some data not to be sent to the cloud. So we remember from the automation pyramid that the amount of data and response times, they were really short here. So we can't send everything to the cloud. We have to decide what is sent to the cloud. Then you could have some basic analytics, data filtering, and so on, depending on how sophisticated your devices are in this layer. Then there's a layer called fog. This is not so often called there, but this is between the cloud and edge. You would have more complex data processing here and also continuous connection to the cloud. This could be, for example, if we think about mobile communication, this could be the base stations, for example. You already have quite massive capability to do data processing there. Still, you have access to the real-time data and really low latencies. And then the cloud is where you have the big data processing, data warehouses, and most probably the AI processing or AI post-processing for the data. And this is where you make the decision. This is where your ERP level is, where you collect all the data from all your machines, all your factories. And here also you see you have much more data and fast in the lower layers and less data and slow here. And IoT strategy, during these 3 days, kind of what I wanted to present is give ideas how to kind of what are the best practices, how to work with different kind of ready-made platforms like no-code, low-code tools, software as a service, function as a service, how you could utilize the automation of processes. So today we focused on the cloud-to-cloud communications, and there are different communication layers and applications, and they really form complex tool chains, so that require management. And the problem in IoT platforms or IoT solutions, if we think about complete IoT ecosystem solution, is how to design each of these layers accordingly, how to choose the correct tools and manage them, and how to minimize costs, maximize benefits, and how to make it future-proof. Those are at least one of the key problems. And you've seen Azure, you've seen IoT ticket. Those are one ways to minimize costs and maximize benefits and focus on business value creation. Automating your software processes. At first, they will increase your costs in the shorthand, but in the long term, they will decrease your costs because they basically make it easier than in the later stage to do changes. The more you have automation, the easier it is to do changes. So in the field level, there is often, this is the factory level, and quite often there is a rule of thumb. So only change if you must. So those running your, or when running your operations and when running your processes, then you don't really want to change things unless you have to. And that's because quite often you have most of the legacy systems are in the field level. But on the other hand, you need to have a interoperability with the legacy systems and same time to have a roadmap how to improve in the future. And OPC UA is one of those reference architectures that basically has to be understood, at least how things are done there. And it's really good reference protocol, reference architecture that gives guidelines that how things should be done in the field level. Then in the edge and fog level, so there is a, let's say, hybrid computing model. So edge is, let's say, an extension to the cloud. So in the edge level, you should optimize your bandwidth by moving the decision making near the device. Some key parameters there are security, scalability, provisioning, deployments, and lifetime management. We've seen the Azure, how to use it for provisioning the devices, MQTT for communicating, publish and subscribe pattern for communicating from device to cloud. There's scalability, there's security, ease of provisioning and deployments. Give some ideas how to create strategies in the edge level. You probably want to create a partner ecosystem. So there's probably if you think about field devices, there's sensors. There's a lot of sensors being invented all the time. Wireless sensors are getting more and more popular. So you would probably like to trust multiple partners from where to get the sensors. For example, Vapais has Virepas and Treon, which we support natively. So those are communication manufacturer and sensor manufacturer. They basically provide a tool chain from field level to the cloud and a mesh networking capability. 5G is something you probably want to follow. That will turbo boost the edge processing and edge communication in the future. And then in the cloud level, so prepare for agile development there also. So achieve the flexibility by using no-code, low-code tools, bypass costly IT projects and change your experts into application designers. Use DevOps in the software design processes. The bigger the project, the better the automation level should be. And then you have the software as a service, platform as a service, and function as a service concepts. Only pay what you use and when you use. Use virtualization and stateless architecture and trusted partners. I was prepared to talk about the artificial intelligence. This was a backup slides, but I think I would like to close on the IoT strategy here and to conclude the 3-day course. It has been really nice to talk to you guys, and I hope I have given some ideas and examples how to work with the cloud tools and some concrete examples also. And yeah, if you want to get in touch, don't hesitate to send a LinkedIn connect or just send me an email for further questions. I'm more than happy to help. And is there any questions?
That was very interesting that Azure use as a cloud. So I play with Raspberry Pi and probably going to try to use it as in the future.
Okay, sounds good. It
yes.
should be
sensor data and that sorts of things at school. I work at school, so
yeah, it should be really straightforward to set up your own IoT hub and then send data from the Raspberry to Azure.
Okay.
And then you can create your post-processing stages after that.
Yes, that sounds very good. I be in touch if I need anything.
Sure. Please do so.
Thank you.
Thank you. Anyone else? Anything open in your mind?
Yeah, thank you very much. I just hope that we will receive the slides, so there would be a way to review all this information.
Yes, I will send the slides to Peter and Anja,
yeah.
And hopefully they will deliver these then further.
Sure, thank you.
No problem.
Yeah, all the PDFs and slides will be available on our website afterwards.
Okay, very good. Thank you, everyone. If no further questions, then I will stop the recording.